Assalamualaikum and hello guys. My name is Haziq. So today I'm gonna to share with you guys about oscillator. Actually oscillator is a chapter 2 from subject electronic circuits. So what is oscillator? Oscillator is an electronic device which generates an AC signal with required frequency, amplitude and wave shape. Okay, oscillator has two class. First is sinusoidal oscillator and non-sinusoidal oscillator. So for sinusoidal oscillator, known as harmonic oscillator, is generate a purely sinusoidal waveform which is constant amplitude and frequency. And second is non-sinusoidal oscillator, known as realization oscillator. It generates complex non-sinusoidal waveform that change very quickly from one condition of stability to another, such as square wave, triangular wave, and sawtooth wave type form.
Okay, as you can see, that is a block diagram of oscillator. The function is oscillator is a device that can change DC voltage to AC voltage.
And four requirement of oscillator circuit has four things. First is power source. Second, device or component that determine the frequency. Third is application of oscillation. And last is positive feedback.
Okay, this is basic oscillator circuit diagram. So you can see feedback, frequency generator circuit, and amplifier to output.
Okay, for a sinusoidal oscillator has a five type. And first is RC phase shift oscillator. Second, Colpit oscillator. Third is Hartley oscillator. Fourth is Armstrong oscillator, and lastly is crystal oscillator. Okay, so what is RC phase shift oscillator? Phase shift oscillator consists of amplifier and feedback channel with 3 RC circuits. This oscillator produces a sine wave output signal using regenerative feedback from the resistor capacitor combination.
Okay, this is a circuit for RC phase shift. So you can see 3 resistor and 3 capacitor. And this is a formula F equal 1 over 2 pi RC square root 6.
The second is Colpit oscillator. The Colpit oscillator uses a pair of tape capacitors, 2 capacitor and single inductor to produce the regenerative feedback necessary of oscillation.
Okay, this is a circuit for Colpit. So in feedback, we have 2 capacitors and 1 inductor. And formula is F equal 1 over 2 pi square root L C total. So we have a C total formula, and we have a feedback factor formula and voltage gain formula.
Third is Hartley oscillator. The Hartley oscillator uses a pair of tape inductors, 2 inductors, and a single capacitor to produce the regenerative feedback necessary of oscillation.
And this is a Hartley circuit. So in feedback, we have 2 inductor and 1 capacitor, different with Colpit circuit. And for formula is F equal 1 over 2 pi square root C L total. So we have a L total formula, feedback factor formula, and voltage gain formula.
And number 4 is Armstrong oscillator. The Armstrong oscillator uses a transformer coupling to produce the regenerative feedback necessary of oscillation.
And this is Armstrong circuit. It's totally different with RC phase, Colpit, and Hartley. For Armstrong circuit, in feedback, they are using transformer. And for formula is F equal 1 over 2 pi square root L2 C2.
And last is crystal oscillator. Crystal oscillator, to obtain a very high level of oscillator stability, a quartz crystal is generally used as the frequency determining device to produce another type of oscillator circuits known generally as a quartz crystal oscillator.
And this is a crystal circuit, so you can see in feedback that is a quartz crystal. Okay, so for the formula, crystal has two formula, is Fs and Fp. Fs is for series resonance and for Fp is parallel resonance. So that is a formula, and we have a formula for C total.
Okay, that's it for today. So thank you for watching.